show. Assignment. Okay. You are. Solution. Make it bigger, 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 bigger.
Because Newton, the first one.
I let you take a photo. First, let's see.
So you're gonna upload in
No, I'm not going to upload anything. Problem. It says the cylinder has a mass of 80 kilograms. A horizontal force P equal to 750 Newton is applied to the cable wrapped around its outer surface. If the cylinder is originally at rest, determine its angular velocity after the center of the cylinder has moved 2 meters. The cylinder rolls without slipping. Neglect the mass of the cube. Now take a look on solution. Solution goes to work energy, but also we are going to use instant center of rotation. Do you know instant center of rotation? Yes. Yes. Okay. Okay. You can take a look. You can. I make it smaller so you have everything in one page. A little bigger. There you go. I leave it to you to read. Take a photo. That's one problem, one solution in detail, and it is principle.
So can you show the first one?
Go back to the first one.
Go back. Exam. Take home. That was take home exam. Oh, it was there. So that was a problem. What took I took it?
Somewhere we are. One put 1.34.
Okay. Good to know. It tricked us. Same problem. What are the velocity of A and B? What is missing? I look at solution. I give you the solution, you can take a photo of solution. What is missing here is that color A is sitting on that. We assume it has free length, but it wasn't. It was sitting on that. So initially, there is a potential energy here. The problem didn't say that, it wasn't clear, so that was my assumption. I assumed that it is free length. But look at the solution here. The solution here, look at this term. MA, I'm taking here. MA G over K is a static deflection. Static deflection. 1/2 K static deflection squared is originally potential energy here that we did not consider. That's why our solution needed a lighter spring, but everything else is correct, as we said. MAGXA goes up, the other one goes down, and that static deflection is here as well. There you go. So that problem, originally, the statement of the problem has problem. It must say that we release, the color A is sitting on a spring at rest. So there is a static deflection. This problem. That was take-home exam. I think it is during the COVID. Means the student had to solve it at home. I don't know, 2 days, 3 days time. A disk of mass M attached to a spring slides on a smooth horizontal table under the action of constant conservation force F. Transverse force. The string is drawn through a hole in the table at O. A constant velocity v0. At t equal to 0, r is equal to r0, and the transverse velocity of the disk is 0. Okay? What is the disk velocity as a function of time? Complicated. Is that clear? What is the question? Forget about the solution. What is the question? The question from top view, this particle is moving. This is R. It has what? It has force. Sorry. Not move. We apply force. This string, it's a table. From bottom, we are moving down with constant velocity. So we are shortening this with constant velocity. It means dr to dt is equal to negative something, v0. We apply a force on that, so show where it is going. We have to go to polar coordinate. So this is a good example for polar coordinate. Now look at the solution. First, take a photo of this. It's a good problem to have practice. And look at the solution. Take a photo of solution. That's it. That's the whole solution. Not bad. A little complicated. This is a good one. Impact. This one is simple. two 10 pounds means mass of these two are equal. So wherever in those equation m1 minus m2, it is 0. Slides on the smooth horizontal bar determine the velocity after they collide. A, if they are coated with what is that? Velcro and stick together. So the material is not important. They are hitting each other and stick together. So after impact, they are not separated. After impact, we have V prime 1 equals to V prime 2, right? If the coefficient of restitution is 0.8. Part A, did you take a photo? You did? Okay, I go to the solution. Part A, the solution is, as I said, we have after impact m1 plus m2 times 1 velocity v. The important part is that part, which we have restitution problem B. So here, solution A, solution B. Simple, actually. The problem was simple, just substitution for numbers twice. 1, full plastic means E equal to 1. Once E was 0.8. Let me see if I find better one. Exam 2 solution. That was exam. 2 problems. In this exam, there were 2 problems. 1 problem. Here is the solution as well, but the student didn't have the solution. 1 problem is impact, uplate impact. The other problem is similar to what we had. This is good one. So take a photo of this. Let me make it bigger. Let's see what it says. A 50 kilogram block at 8 is mounted on the roller so that it moves along the fixed horizontal rate with negligible friction under the action of the constant 300 Newton force in the cable. The block is released from rest at 8 with the spring to which it is attached extended an initial amount of 0.234. That was good one. It explains that originally the spring was extended, so the block was moved a little. Now velocity is 0 and I let it go. So originally or initially there is some potential energy in the spring. Calculate the velocity of V of the block as it reaches position B. Means block A moves 1.2 meter. Initially it had x1 displacement. The solution is similar, but I let you take a photo. Here you go. Well, take one photo here so you have part of the solution. And then I move down. Here, finished. How about the spring? In the spring, we had had several exam final. Okay. This is exam final. Sorry, no solution here. I find the solution. Let me see. Final exam. I don't see the solution here. The disk starts from rest and is given an angular acceleration alpha equals to 100 cube root, or no, 10 theta to the power of 1/3 radian per second squared, where theta is in radian. Determine the magnitude of the normal and tangential components of acceleration of a point P on the ring when t is equal to 4 seconds. So it is polar coordinate system, acceleration, and then numerical values to calculate tangential and normal components of acceleration. Let me solve it because I didn't solve any example, numeric example, for those polar. I assume it is easy, which is easy, but let's do once at least here. So what we have is a circle, 1 point here, and it is starting with omega or alpha. Alpha is given 10 cube root of theta, radian per second squared. Is that right? Acceleration is what? At t equals to 4 seconds. That's the question. Right? Double check. That's it. If you remember, we had A is equal to rho double dot minus rho theta dot square E rho plus rho theta double dot plus 2 rho dot theta dot E theta. This is radial, this is tangential. In this example, rho is equal to 0.4 meter. 0.4 meter. Rho is 0.4 meter. CTE means constant. So it means rho dot is 0, rho double dot is 0. It says that A is equal to minus rho theta dot square E rho or U rho. Sorry, I used U unit vector last time. Here I'm using E. It is confusing. It is confusing. Let's be consistent. And here I have plus rho theta double dot E theta, U theta. When radius is constant, we always have centripetal acceleration in radial direction and tangential acceleration rho theta double dot. That's it. Now, what I have is this. Theta double dot is equal to 10 theta to the power of 1/3. Theta double dot, what a rate. Damn. Theta double dot 10
10
It is similar to say x double dot or a is equal to 10 square root x cubed. It means I can say that this is how can I solve this problem? How can I solve it? It's d omega to dt equals to 10 theta to the
6
1/3.
crazy.
So d omega is equal to 10 theta to the power of 1/3 dt. This part I have omega equals to 10 theta to the power of 1/3 t.
6
No, that's wrong. That's wrong. Don't write it. This is wrong. This is wrong. Yeah, how can I solve it?
Today what?
I like to go. Where are you? I like to use.
No, you got those. Just our class ends by 5:30. But today it's until
6, 6,
7.
6, 6.
Hey, I did.
Oh, you said class is over.
No.
Somebody said. Back here.
Survey.
Let me finish this problem. I like to use this equation. A dx is equal to v dv.
한빙묘 하면
So is it for linear, right? Is it for linear or?
No, I reminded you here we have alpha d theta equal to omega d omega. Right? If that's true, then alpha d theta is equal to omega d omega. So integral alpha is here, so I have 10 theta to the power of 1/3 d theta is equal to 1/2 omega squared. 0 to omega, 0 to theta. Now, give me this integral. Give me that integral. It's theta, 1 plus divided, so it is 10 theta to the power of 4/3 divided by 4/3, or 3 times over 4. 1/2 omega squared. So from that equation, I get this theta. I get what? Omega squared is equal to 2, 5, 15 theta to the power of 4. 3. Am I right? Am I right here? Say yes, you're right. Am I? Look, if we knew theta, then omega squared is enough to go here. R omega squared, this component. Theta double dot was given to me, comes here and gives me that component. But the value of theta is not given, so we have to integrate that to find theta as a function of time. Put time equal to 4 seconds. Where is that? Here. T equal to 4 seconds, find theta. So in that equation, I'm using this. Sorry? I have omega equals to square root 15 theta to the power of 2/3. Am I right? I'm taking a square root of both sides to find omega. And omega means theta dot, means d theta to dt equals to square root 15 theta to the power of 2/3. So d theta divided by theta to the power of 2/3 equals to square root 15 dt. Integral of theta to the power of minus 2/3 d theta 0 to theta is equal to square root 15 times t.
For your
Is that right?
on your iPhone.
Yes, no.
Yeah.
Thank you. What did I do from the beginning? This problem, which is not that simple, acceleration angular is given as a function of position. I used this equation, ADX equals to VDV. Equivalent to alpha d theta is omega d omega. Takes integral. Why we can do that? Because we have alpha as a function of theta. So when I put it here, this side is just a function of theta. The other side, omega d omega is 1/2 omega squared. Substitute everything, calculate omega as a function of theta. Now it is easy because omega is d theta to dt. dt goes here, this part goes here, so I have this integral. And it says theta to the power of 1/3 divided by 1/3 equals to square root 15 times t. So theta is equal to
Whiteboard 那个 projector 领导。
square root 15 divided by 3
他也是领导啊。
times t, everything to the power of 3. Then theta at t equals to 4 is theta is equal to 4. Give me the number. Square root 15 times 4 divided by 3 to the power of 3. And ask me to explain again.
Can
Number?
you explain what's the omega square equals 15? Yeah.
Omega square is 15. Oh, useful.
How you get theta 4 over 3?
Theta 4. Integral of 10 theta to the power of 1/3 d theta. It's theta to the power plus 1 divided by that. So divided by 4 over 3. 3 comes to the numerator times 10. Yes?
But how you get like 2 over 3 for it?
That's
Times 1 by 2.
1 by
Oh, that's not.
Times 1 by
4
2.
by 3.
This one is okay? So from this equation, I get omega equals to 10. Then I take square root. Square root of theta to the power of 4 over 3 is theta to the power of 2 over 3. Am I right?
Yeah.
So the rest of it. Give me this number.
137.7.
137.7 radian.
No, degree.
Give me radian. Give me radian. Everything is in radian.
Oh, okay. Then correct, right? Yeah.
That was correct. 137.
137.7.
137.7. Now, this theta goes here. Give me omega. Put theta here. Give me omega. 3.6. 3. Then give me alpha. Alpha here. Theta, we know that. Put it here. Give me alpha. Here. Give me alpha. Root 3. Don't forget.
以前的 camera factor 因为这样摩托太多 messed up the camera stable 是我啊
Alpha.
是啥你放在那个摩托里面我一直这样 messed up the camera stable
51.64 radian per cubic second. That was radian per second. So finally we have tangential
有是这样
acceleration,
surrounding with flicker
which is A tangential, which
frequency
is equal to
frequency 有问题，
R theta double
不
dot
是 camera 坏
All
frequency，我的是这个
alpha. R is 0.4, so it is 0.4 times 51.64.
projector frequency 错，
Radial acceleration is A radial, which is equal to minus R omega squared, which is minus 0.4 times 100 times 100, 3.3. I wrote it very badly. 0.4 times 100, 3.3. That's it. That was the whole solution of this problem. I gave it to students